Hello everyone, welcome to Clean Copper Talks. This is part 2 of National Clean Air Program. In part 1 we have seen in detail about the National Clean Air Program, but there are certain things related to National Clean Air Program such as National Ambient Air Quality Standards, Air Quality Index, which I think is must for people who are from environmental background, who are from air pollution background, who wants to work on air pollution should know them. So this is a short video just sharing the technical details about such national ambient air quality standards. So please stay till the last so that you can know the detailed information about such air pollution standards. So we have seen what is national clean air program. It was launched in 2019, but before that the national ambient air quality standards were already in practice, and in 2009 the government of India, or rather say the Central Pollution Control Board, had revised the national ambient air quality standards in 2009, which under the Air Prevention and Control of Pollution Act 1981. So in 2009 they added PM 2.5, ozone, benzene, lead and nickel in the national ambient air quality standards. So the final national ambient air quality standards is what is shown here. PM10 is the particulate matter size less than 10 micrometer but greater than 2.5 micrometer. PM 2.5 is less than 2.5 micrometer size. Then sulfur dioxide, nitrogen dioxide, ozone, lead, carbon monoxide, ammonia, benzene, PAHs, arsenic and nickel. All these average annual or 1 hour average has been mentioned here. Then these are the average for 24 hours, or if they are carcinogenic or toxic, that has also been mentioned here. So when we say annual average, that means at least 104 measurements. That means at least two measurements twice a year. So there are different types of monitoring stations. Either the monitoring stations are continuous monitoring, or they are uh, manual monitoring. So if it is a manual monitoring, at least two times a week the monitoring should be there. Otherwise, at least uh, otherwise, if in continuous monitoring, everyday monitoring can be done. So for monitoring, devices such as high volume air sampler are used, which is shown here. This is a schematic diagram of a high volume air sampler. What happens is the air continuously flows from here. Then there is a filter. First we will place a filter of 10 micrometer. Below that there will be another filter of 2.5 micrometer. Then there will be another impingers, which is not shown here. There will be impingers, and impingers will have different type of solvents. These solvents are used to absorb nitrous oxide, sulfur oxide, ozone, lead, or whatever parameter we want to measure. So the reagents which absorb such parameter are kept in spingers, in spingers over there, and then after that the air moves out. So whatever the particulate matter is there, that gets adsorbed over the surface of filter. Then if there is SOx, NOx or lead or nickel or any another parameter which you want to measure, that gets absorbed in the impingers reagent, and finally the air goes out there. And for any city, this I have taken from researchgate. Someone's study is there. I would like to thank them for this. So anyway, this is a map of Delhi. This is a map of Delhi, and what it shows is the location of various continuous air monitoring station, then manual air monitoring station, and they have also circled the monitoring station which they are using for this study. Anyway, my intention was just to show you that in any city they divide it in zones, different zones, and for the zones then they mark the places where ambient air quality will be measured, and the continuous monitoring or the manual monitoring data is finally transferred to the CPCB for their records. Okay, so these ambient national ambient air quality standards which were in place in 2000, which came in place in 2009, are stricter than the previous ambient air quality standards, but still they are less stringent than those uh, informed by World Health Organization. And national ambient air quality standards are used by NCAP as a reference to decide whether a city is polluting or not polluting. Now there are different modeling softwares which are used to model and forecast the air pollution, such as CMAC, Community Multi-Scale Air Quality Model, or the WRF CAM. Then CalPUF is there, Air Mode is there, High Split is there, and India specific Suffer is there. These models, what they use, they need the data, continuous monitoring data. What we are doing with the data, this data are fed in such models, and then they will forecast depending on the conditions that uh, what or how the air quality will be there in coming future. So doing for modeling and air forecasting, they just don't need only the parameters which are monitored, such as um, PM10, PM2.5, SOx, NOx, ozone, lead, nickel, but the climate parameters such as wind speed, wind direction, climate conditions, humidity, temperature, all these data are also required to have a very confident forecasting of air quality in future. Finally, you would have seen air quality index being shown at different places in your city. What is an index? Index is a unitless number. So for air quality index, it ranges between 0 to 500. That means if air quality is 500, you will instantly understand that the air quality is bad, or if it is less than 100, you will understand that air quality is good. So but you don't know the inside details, that how is the PM10, how is the PM2.5, if there is lead or ozone in the air. You don't know those things. And for a common person who is not from environment background, who is not from chemical background, let's say he is a software engineer, or let's say he is a football player, so they don't need to know all those details about the each parameter. They just need the overall quality of air. And so that is what air quality index or any quality index such as wastewater quality index will do. Index will always be a unitless number which will tell you how the quality of that particular thing is. If we are talking about air quality index, that means it will tell you how the air quality in general is. This is for a common people so that they can instantly understand how is the quality of air. So to get into air quality index, there are different methods such as arithmetic mean method, geometric mean method, or principal component analysis based method, or Delphi method. There are different methods which can be used to define the air quality index. So you need the formulas based on a particular method. Then you need the values of all the concentration of parameters which are monitored. When you feed those data into the equation, you will get the air quality index, and that will tell you whether the air quality is good, satisfactory, moderate, poor, very poor, or severe. All right. So this is a small details which I thought is important for someone who is from environmental background and who wants to know the details about the air quality. I hope you like this video. If yes, please subscribe to the channel and hit that like button. I will see you in next video. Till then, tata, bye bye, take care.